What if you woke up tomorrow to find out that Yellowstone was on the brink of eruption? Imagine the headlines, the global alarm. Nestled in the expansive wilds of the United States, the Yellowstone caldera is not just any volcano, it's a supervolcano. This title is well-earned, given its colossal chamber of molten rock lurking beneath the serene landscapes of Yellowstone National Park. Often termed a sleeping giant, Yellowstone is both a source of fascination and fear. This stems from its sheer power and the unpredictability of its activity. Despite its tranquil appearance, the ground beneath Yellowstone holds a tumultuous history of massive eruptions, the most recent of which occurred roughly 640,000 years ago. These events were so powerful they have left deep imprints on the landscape and the climate. This scenario might sound like a plot out of a science fiction movie, but the reality could be more imminent than we think. To truly understand the threat of Yellowstone, we first need to dive into what makes it tick. Beneath the breathtaking landscapes of Yellowstone National Park lies a sleeping giant, not just any ordinary volcano, but a supervolcano. At its heart is an enormous magma chamber, a colossal underground pool of molten rock that stretches for miles. This chamber is fed by a hotspot, a plume of heat rising from deep within the Earth's mantle. Unlike most volcanoes which are driven by tectonic plate movements, the Yellowstone supervolcano is powered by this hotspot which has been active for millions of years. Now imagine this hotspot as a relentless blowtorch, continuously melting the rock above it. Over time, this process forms magma, which accumulates, creating immense pressure beneath the Earth's surface. The ground above this magma chamber is not static. It swells and stretches, adjusting to the pressures below. This is known as ground deformation, a critical sign of what's happening beneath the surface. Seismic activity, another vital clue, accompanies this deformation. Earthquakes are common in Yellowstone, though most are too small to be felt. However, their frequency and patterns can be a telltale sign of changes in magma flow and pressure buildup. Scientists meticulously monitor these earthquakes, using them to map the subterranean magma and assess any shifts in activity. This monitoring is crucial because the behavior of the magma chamber and the hotspot can inform predictions about future eruptions. The data gathered helps scientists understand not just when the supervolcano might erupt, but how such an event might unfold. Techniques like satellite imagery and ground-based sensors provide a continuous stream of data, painting a detailed picture of the underground dynamics. So with this ticking magma chamber, how do scientists predict what comes next? Experts around the globe keep their eyes glued to Yellowstone, each with their own insights on its temper. Volcanologist Dr. Emily Rosenthal shares that the magma chamber beneath Yellowstone is exceptionally large, capable of producing a super eruption that could alter global climates. She uses thermal imaging to study the heat patterns beneath the surface, which can indicate rising levels of activity. Geologist Dr. Mark Benson focuses on the gas emissions from Yellowstone's numerous geothermal features. The gases released, especially sulfur dioxide and carbon dioxide, are key indicators of magma movement, he explains. By monitoring these emissions, scientists can detect shifts in the underground magma chamber, potentially predicting increased volcanic activity. Both experts utilize seismic data, as Yellowstone is one of the most seismically active areas in the United States. Dr. Rosenthal notes, a sudden increase in earthquake swarms could be a precursor to eruptive activity. It's crucial we monitor these tremors closely. Despite their different approaches, both agree on the importance of continuous monitoring. The data collected helps paint a clearer picture of what might be brewing beneath the surface. Dr. Benson adds, understanding the timeline for an eruption involves piecing together geological history with current data. It's like putting together a massive dynamic puzzle. While opinions vary, the consensus is clear. The question is not if Yellowstone will erupt, but when. Imagine a giant beneath your feet, just starting to stir from its sleep. This giant isn't from a fairy tale, but rather Yellowstone National Park, home to one of the world's largest supervolcanoes. Recently, signs have begun to emerge that hint at the giant's reawakening. First, let's dive into seismic activity. Yellowstone is no stranger to earthquakes, which are common indicators of volcanic activity. The park experiences thousands of small tremors each year. However, it's the patterns of these earthquakes that catch the eye of volcanologists. An uptick in frequency or intensity can be a sign that magma is moving beneath the surface, stressing the earth above it. Next, consider the changes in the park's hydrothermal systems. These systems are essentially the plumbing of the supervolcano, a complex network of water heated by the underlying magma. Changes, such as new or more vigorous geysers, or alterations in water temperature and chemistry can suggest shifts in the underground magma chambers. For instance, a sudden release of gases like carbon dioxide and hydrogen sulfide is often a telltale sign of increasing volcanic activity. Then there's ground uplift, a phenomenon where the Earth's surface begins to swell. This is caused by magma filling the reservoirs beneath the park, pushing the ground upward. Modern technology allows scientists to monitor these changes with precise GPS measurements, revealing even minor elevations that might not be visible to the naked eye. These signs are closely monitored, as they could be the harbingers of a catastrophic awakening. The eruption of Yellowstone could be one of the most significant events in human history. Imagine a world blanketed in ash, the skies darkened for months, even years. This isn't the plot of a dystopian novel, it's a very real scenario if the Yellowstone supervolcano were to erupt fully. The immediate aftermath would be devastating, but the long-term global consequences, they could alter the course of human civilization. Firstly, let's talk climate. A full-scale eruption at Yellowstone is predicted to spew vast amounts of volcanic ash and sulfur dioxide into the stratosphere, leading to what's known as a volcanic winter. This phenomenon dramatically reduces the amount of sunlight reaching the Earth's surface, cooling the global climate. Historical eruptions have given us a glimpse of this chilling possibility. The year without a summer in 1816, caused by the eruption of Mount Tambora, led to widespread crop failures and food shortages. Now, scale that up to a Yellowstone eruption, and the picture becomes grimmer, with potentially several degrees drop in global temperatures. So when will Yellowstone erupt? Are we in the final countdown? The question is as intriguing as it is complex. Yellowstone, a massive caldera, lying beneath one of America's most beloved national parks, has been the subject of intense study and speculation. Despite centuries of observation and decades of modern scientific research, the timing of Yellowstone's next eruption remains shrouded in mystery. Experts largely agree that there is no imminent threat of an eruption. The supervolcano last erupted approximately 640,000 years ago, and such events are not frequent on human timescales. However, the potential power of such an eruption drives the scientific community to monitor the volcano closely. Research indicates that the signs leading up to a super eruption would be impossible to overlook. Ground deformation, increased seismic activity, and changes in gas emissions would all escalate in a way that is distinct from the regular background activity we monitor today. Currently, none of these indicators suggest an impending eruption. Advancements in technology and geosciences hold promise for improving our predictive capabilities. Satellite imagery now allows scientists to monitor ground deformation from space with unprecedented precision. Seismic networks have grown denser, providing better data to analyze the underground movements of magma. Chemical sensors can detect even minute changes in gas compositions, offering clues about magma's movement and pressure. Artificial intelligence is also becoming a pivotal tool. By feeding historical data and real-time monitoring into machine learning models, scientists are beginning to forecast volcanic activity with improved accuracy. These technologies could one day provide enough warning to mitigate the impacts of an eruption effectively. Yet, despite these advancements, predicting the exact timing of Yellowstone's next eruption is beyond our current scientific reach. The systems involved are incredibly complex, influenced by countless variables that interact in ways not yet fully understood. While the exact time remains unknown, the importance of continued vigilance and research cannot be overstated. For now, Yellowstone remains a stunning natural wonder, closely watched by the eyes of science, ensuring that we remain as prepared as possible for whatever lies beneath.